Hello guys, welcome to Zeta Axis, and today we will be discussing about continental drift theory. In this topic we will discuss the pre-continental drift theory, that is the theory which existed before continental drift theory, the continental drift theory given by Wegner, the evidences he suggested, the forces he suggested for the continental drift, and the cause of rejection of Wegner's theory. So before continental drift theory there existed a theory, earth contracting theory, which explained why mountains and other landforms were formed on the surface of the earth. This theory said that the earth was formed of molten rocks, and these rocks were very hot when the earth was formed, but slowly these rocks started to cool down, and when anything cools down it started to shrink or it starts to contract. And this theory said that these hot rocks, when started to cool down, they started to shrink, they started to contract. Now because different parts of the earth were made of different elements, each element or each region contracted as different regions, forming mountains as well as valleys. The valleys got filled with water, creating oceans. This theory also suggested that there existed structures like this called land bridges, and these were the parts which connected two bigger land masses like big continents, and this was the small link in between them. Now even these small parts got submerged within water as our earth continued to shrink, and it continued, and the theory says the earth, even in 1900s, that the earth continued to shrink down. Now this theory was obviously not right, and it has been completely rejected today, but understanding this theory will help you understand why continental drift theory got rejected at the first place. So coming down to Wegner, Wegner was basically a meteorologist and a climatologist. He had paid many expeditions to Greenland for a study of climates and other things related to his field. But during these expeditions, he had made many observations which led him to believe that the continents are not stationary but are continuously mobile, moving from one place to another very slowly. He published his concepts in 1912 and called it continental drift theory. He said that the continents are not stationary but are continuously in motion. Now, Wegner was not the first person to suggest this. There were many people before him who suggested the same thing, but Wegner was the person who gave the most extensive and irrefutable evidences. That is why we say that continental drift theory was given by Alfred Wegner. Now one more thing is that we have seen that Wegner was a meteorologist and a climatologist. He was not a geologist. And this was one of the main reasons he could not give a proper support for his understanding, that is the movement of the continents, and that is why his theory got rejected. We will see this later in our lecture, that why exactly it got rejected. Now let's first see what was continental drift theory. Wegner suggested that initially all of these continents were one single block, that is all these land masses were connected together, and this land mass which was connected together was called Pangea. There was one single ocean which surrounded this Pangea, and it was called Panthalassa. He stated that around 200 million years ago, this Pangea started to break down, and it broke down into two parts: Laurasia, which is the northern part of Pangea, and it formed into North America, Europe and Asia, while the other was Gondwana land, which was the southern part of the Pangea, and it included South America, Africa, India, Australia and other parts of our earth. Wegner further suggested that even these land masses further divided to form the continents that we see today. Wegner suggested that continental crust moves upon an oceanic crust, and he suggested that it moves like an icebreaker ship moves over ice sheets in the polar region. So you can see that this is whole ice and this is a icebreaker, and you can see that this whole ice sheet has been broken down in the trailing edge of our ship, and even in the further regions or in the forward region of this ship, there are cracks within the ice because of the weight of this ship. So he suggested that in similar manner continental crusts move over oceanic crusts. He further had stated that Pangea was formed near to the southern pole. So you can see that you can place equator somewhere around here. So most of the landforms or land masses were closer to the southern pole. So you can see our India, Australia, Antarctica, Africa, all these were very close to the southern pole. He suggested that Pangea, when once broke, it moved into two directions. And equator what direction? That is the northern part of the Pangea moving towards the equator, as well as the southern parts of continents moving towards the equator. And secondly, that some continents move towards the westward direction. So you can see that even this was from the observation of his Pangea map and the current map of the world. He saw that the American continents, that is the North America and South America, they have moved towards the western direction, while all other parts like Laurasia, which is now Europe, and Asia, that is Eurasia, has moved towards the equator. Similarly, all these land masses have moved slightly towards the equator except for Antarctica. He further suggested that because of these movements, the margins of the continents facing the movement led to the formation of mountains there. And he suggested that because our South America moved towards the western direction, its western margin has Andes. Similarly, North America, which moved towards the western direction, has Rockies, Cascade Mountains, and other mountains in the western region. For India, he said that because India was somewhere here and moved towards the northern direction, the northern margin has Himalayas, and Europe, which was somewhere around here, moved towards the equator in the southern direction. Therefore, its southern margin has Alps. So in a way, Wegner tried to describe the mountain building process through his theory. Wegner suggested few forces responsible for causing this continental drift theory. Now, we will see these forces in detail a little later in the lecture, but right now we will just mention them. So, first one was pole fleeing forces, that is centrifugal force, which caused the continents to move towards the equator. So, he said that the centrifugal force caused the continents to move towards equator. Then he said that tidal forces of sun and moon caused continent to move westwards, that is in the western direction. He further said that because of the ellipsoid shape of our earth, that is, earth is little bulged on the equator and little flattened on the poles, and that is why, because of that, there was a gravitational differential force between the gravitation and the buoyancy, creating a net force towards the equator. He also said that precession of axis of rotation of earth was one of the responsible causes for movement of continental blocks. We will see all these forces in detail a little later. Now let's see what evidences of continental drift theory Wegner had suggested. This is a complete list of theories suggested by Wegner, and we will see each of them one by one. The first is coal seams in high latitude regions. Wegner has observed that coal seams were found in Antarctica as well as northwestern part of Europe. But formation of coals requires a large amount of vegetation to be buried under layers of earth before they could get decomposition. And for this to happen, there must be some sort of swampy land or wetlands, and there should be a large amount of vegetation available. But in Antarctica, it is not possible to have dense forest because of the extreme climatic conditions existing there. Moreover, existence of wetlands or swampy lands is not possible here. That is why Wegner thought that Antarctica must be a little towards the equator somewhere in the history for these coal seams to be formed there. Next is pole wandering theory. Now this theory is based on the concept or based on the idea that when we take a magnetic needle, the magnetic needle will point towards the North Pole, magnetic North Pole. Moreover, the magnetic needle will show an angle of inclination. It will be inclined to the horizontal based on the location of that magnetic needle on the earth. This is because our magnetic fields that emerge from the magnetic North Pole, they go all around our earth and then come back to the southern magnetic pole. So the magnetic needle, which is like blue and red colored here, so this magnetic needle will be aligned to the magnetic field at that location. So here at the equator, this magnetic needle is completely parallel to the magnetic field lines at equator. You can see here that it is going up and down. So that is why this needle is aligned up and down, and it is in complete alignment of the horizontal surface. But as we move northwards, as we move higher in latitudes, you will see that the magnetic needle now is again parallel to the magnetic field line here, but it is not aligned with the horizontal direction. And if you come to the poles, you will see that the needle is completely 90 degree because the magnetic field here is 90 degree to the surface of Earth. This difference in angle between the magnetic needle and the horizontal surface is what we call angle of inclination or pole dip. Now, one thing to observe here is that pole dip is 0 here because the magnetic needle is completely aligned with the horizontal direction or horizontal surface. But as we go higher in latitudes, the angle of inclination or the pole dip increases. You can see here it is increasing, and it increases up to 90 degree till we reach the poles. Now, the rocks which come from deep inside the Earth, that is the magma that comes, it has a large amount of magnetic materials like iron and other things. And the magma that comes from within deep is very hot and is in fluid structure. So these magnetic elements can easily align to the magnetic field at that location. So suppose if the magma comes out at equator, then the magnetic elements within the magma will be aligned to the magnetic field at that location. That means it will have 0 degree of inclination and it will point to the north pole at that position. Now slowly this magma solidifies and the rocks or the magnetic elements in the rocks will preserve the position of the magnetic poles at that location when the rock was solidified. And studying this orientation of magnetic elements within the rocks helps scientists to identify where exactly the rock was formed, because as we already discussed, the angle of dip increases with latitude. If the angle of dip of the magnetic elements of the rocks is 0, we can easily know that it was at equator, and if it is 90 degree, we can easily know that the rocks were formed at the poles. And for any value between these two, we can still derive the latitude at which it was formed. Now, using this property, scientists in the past have tried to locate the position of the North Pole. What they did was they take rocks for some year like 200 million years ago. So they took rocks of 200 million years ago and they saw those rocks and they tried to identify where the magnetic elements in this rock point towards. The point they point towards would be the North Pole 200 million years ago. Similarly, they took rocks of all those years, intervening years, and they tried to pinpoint the location of the North Pole, and they drew different path of the North Pole on the Earth's surface. But then came a dilemma or difference. When they took the rocks of African continent, the North Pole showed this kind of position. So you can see that this would be the position of North Pole 200 million years ago according to rocks of Africa, while according to the rocks of Europe, this should be the North Pole. And similarly for North American rocks, they indicated that the North Pole 200 million years ago would be at some point here. And for all the subsequent years, they traced the path, and you can see that rocks from all the 3 continents show a different location of North Pole until today. So this means that either the continents must have moved or the North Pole must have moved, because if this was not the case, then all these 3 studies should have pointed to a single location. So scientists confirmed that either the continents were in motion or the magnetic pole was in motion, or both were in motion. So let's see how pole wandering theory helps us understand our continental drift theory. So scientists took many old rocks and studied the orientation of their magnetic field. What they found that the magnetic orientation of these rocks were not aligned to the current magnetic orientation at that location. So this was a clear implication that either the magnetic pole has moved or the continents have moved or both have moved. Similarly, what they took was they took old rocks from a continent and tried to see where they indicate the North Pole. But they found that all the old rocks from the same continent of a given time showed similar position of North Pole, but that North Pole was not our current North Pole. Again, this implied that either the continents have moved or the North Pole has moved or both have moved. But when they took rocks from different continents of the same time and they tried to see the North Pole location, again, all these rocks from different continents showed different locations. So as we have seen earlier, the rocks from Africa showed a different position of North Pole, the rocks from America showed different positions of North Pole, the rocks from Africa showed different position of North Pole, and the rocks from Europe showed different position of North Pole. So all the three continents rocks gave a different reading of the North Pole, and this was a very clear indication that the continents must have moved, because if it was the North Pole moving itself, then all the rocks from three locations or three continents would have pointed to the same point. And as we have seen earlier, that when the scientists tried to locate the North Pole using these rocks data, they found that all rocks from these three continents would give a different location of North Pole over time. And this was a clear indication that it was the continents that they must have moved. Otherwise, all the rocks from these three continents of the given time should have pointed to a single location if the continents would have not moved. So this was a very clear and very strong evidence for continental drift theory. Another important observational point was jigsaw fit. Wegner basically observed mainly that the western margins of Africa and eastern margins of South America were a perfect match. Similarly, eastern margin of North America and western margin of Northern Africa were also very closely relevant, and there were also certain regions, like you can see the Southern Australian and this part of Antarctica, the Mozambique and Eastern Africa. So all these margins looked like they have been broken down from one single piece, and this all looked like a jigsaw puzzle which we have played in our childhood. So this gave a very clear evidence to Wegner that all these continents must have been joined sometime back in the past. He also gave similarity of fossils across the continent. So while he was trying to come up with proofs, he found a paper in which the person has enlisted certain animals or certain fossils which were spread across the whole world, and he saw that these little land reptiles, both of them are land reptiles, and they are spread across continents which are divided by such vast oceans. You can see here that Atlantic Ocean is there between South America and Africa. Still, this animal was found in both of these regions. Now, it was not possible for both of these to cross such large distances. Similarly, found a freshwater reptile to have been existed both in South America and Africa. Now, for a freshwater reptile, it was not possible to travel such large distance across oceans, and similar case existed for one which was found to be located right from Australia, Antarctica, India, Mozambique, Africa. So it was spread across the world. This was a very certain evidence in the eyes of Wegner that all these regions must have been co-located or must have been joined together, because he was quite clear that it was impossible for those organisms to cross such vast oceans as we have seen. And he also said that it was impossible for each region to have parallel evolution. So he said that it is not possible that each of these regions would have gone the process of evolution to come out into a similar kind of organisms or plants. So he was quite confident based on this that all these regions must have been together at certain point of time. Wegner also studied the oldest rocks found on the earth. Now, Cratons are the oldest rocks on earth, and each continent have some regions formed of Cratons. What Wegner did, he studied these rocks and he found that the Cratons across the continent matched. You can see here the Cratons here as well as these African Cratons were perfectly matched in their origins, in their structure. Similarly, Cratons across North Africa and South America, they also matched. And similar things are found across North America and Greenland, moreover India, Atlantica. So you can see that Cratons across these regions were perfect match, and so this led him to believe that these Cratons must have been together as one structure, and they would have been some point in the past must have been broken down into different parts. So this gave him quite confidence that all these continents were again co-located. This is a bigger map of the Cratons, so that you can see that how these Cratons of Africa, India and Atlantica are similar in origin. Similarly, you can observe for other parts. The next thing he observed was the mountain regions of Eastern America, Greenland and the Western Europe as well as Western Africa. So he found that these mountains were formed in a certain time period which was called Caledonian orography time. So orography is basically process of forming of mountains. A given time, that is around 490 to 390 million years ago, these Caledonian mountains were formed. So this is called Caledonian orography. And he saw that mountains across the Atlantic on both sides, that is eastern side of North America, Greenland, and western side of Europe, were of similar nature, similar kind, similar origin, similar structure. He even saw another orographic event that occurred, that is called Hercynian mountain building belt, which existed in Europe from here, in Spain, Africa, and similarly you can see here a belt in eastern North America. So along another time period also showed that these mountains which were formed during this time period, that is 380 to 280 million years ago, which is a middle Carboniferous era. So both of these mountain structures led him to believe that the mountains of eastern North America and western Europe and western Africa are similar in structure. And this is not a coincidence, but this must have happened because all these mountains were formed together in the past. One of the most significant evidences that he found was Tillite deposits. Now Tillite deposits are basically glacier deposits. These are the deposits which are created by glaciers, and he found these Tillite deposits spread all across Southern America, Africa, India, Australia, and Antarctica. Well, Antarctica you can say is close to pole, so glacier formation is no big deal there. But glacier formation in India, which is very close to equator, similarly in Africa. So the current climatic conditions does not allow formation of glaciation here. So Wegner was of the thought that these all land regions must have been close to South Pole somewhere in the time when glaciation occurred here. The Tillite deposits you can see in this enlarged map, and it was during the Carboniferous period. So you can see that these glacier deposits were not only found here, but they were found in a similar time period. So Wegner was confident that this could not be a coincidence, but these all glaciations must have taken place simultaneously when all these landforms were together. There were certain other evidences like placer deposits of Ghana. So Ghana has on its coastal region a lot of gold deposits, but it has no gold seams or no rocks through which these placers could be formed. But we see that the Brazilian western coast has a lot of gold veins, which implies that these two regions must be connected together, and the placer deposits of Ghana must have come from the rocks of western coast of Brazil. There was also a study which showed that the western coast of South America and the eastern coast of Africa has similar forms of rocks which must have been formed together or being together in the past. Study also revealed that Atlantic Ocean is no older than 200 million years ago. So the study showed that Atlantic Ocean is very young, and before 200 million years ago, Atlantic Ocean may not have even existed. Now, after giving these evidences, Wegner has to give the cause or the forces causing the gravitational drift. Now, as we have discussed earlier, he was not a geologist, so he was not able to come up with a very solid geophysical evidence. In fact, some of his calculations were very mistaken or very wrong. But still, let's take what were the forces he suggested. So Wegner said that post breakup of the Pangea moved into two directions, that is equatorwards and westwards. Now he said that pole fleeing forces, that is the centrifugal forces, caused the continents to move towards equator. We have already seen that he has said that the Pangea blocks moved in two directions, equatorwards and westwards. So he said that pole fleeing force were responsible for equatorwards movement. And how? Let's see. So we see this is a diagram of centrifugal force, and you can see that centrifugal force, which is F, depends on radius, and where radius is the radius of the earth from the axis of rotation. And we can see that this radius is maximum at the equator while minimum at the pole. So you can see that the force of centrifugal force is maximum at the equator and it reduces towards the pole. Now when we take this centrifugal force at a point, this is the centrifugal force pointing outwards at the surface. So it can have two components. One of that components is horizontal component, and that is pointed towards the equator. Similarly, if you take a centrifugal force in the northern hemisphere, it will again the component of it will point towards the equator again. So Wegner was of the belief that it is this component of centrifugal force which caused the continent blocks to move towards the equator. However, when calculations were done by the geologists, they found that this force or this component was too weak for the continents to move them. The next force is suggested was tidal force. And let's try to understand what is a tidal force. We all know that Earth revolves around the Sun in an elliptical path. So in some parts it is very far away from the Sun, and in some parts it is very close to our Sun. So the gravitational force is minimum here when it is the furthest, and maximum when it is the closest. And because of this varying gravitational force, there is certain distortions in the shape of our Earth. You can see that the shape is bulging. It bulges when it is closest to the Sun, and it is expands when it is further away from the Sun. So he said that this tidal force was the cause of movement of the continents. Moreover, he said one more thing, that if we suppose that our Sun is located here, right above this, so when our Earth is moving like this, so you will see that the land masses which are moving west to east, the gravitational force of the Sun will try to pull them westwards. If you can see that the continents are moving toward that direction and the Sun is located right here, the Sun's gravitational force will be trying to hold them their position, and that is why Wegner thought that this gravitational force of our Sun will move the continents westwards. However, again, when the calculations were done, this force was not found to be significant enough to cause the continental drift. Another reason which Wegner gave was ellipsoid shape of Earth. So he said that the shape of Earth is ellipsoid. You can see here that it is more bulged at the equator while it is flattened out at the poles. Now he said that because of this, what happens that normally the force of buoyancy, we all know that the crust of Earth is floating on a magma layer, that is asthenosphere, and this layer of asthenosphere exerts a upward direction force on the crust or on the lithosphere. This is what we call buoyancy, while the weight of our continental block exerts a downward pressure because of the gravity. So these two forces generally are in balance with each other, you can see here. But what happens because of this ellipsoid shape, when we go in higher latitudes, the direction of buoyancy force and the direction of gravity force are not aligned, but they have a certain difference in directions. And because of this difference in direction, you can see here, there will be a resultant force towards the equator in both hemispheres. So Wegner calculated, and he said that it is because of this misalignment of gravitational force and buoyancy in higher latitudes, which gives a differential force in the direction of equator, and this is responsible for the movement of continental plates. However, when calculated, again, this was not found to be significant enough. Now, precession of axis of rotation of Earth. Let's first see what is precession. So you can see here, this is the top view of our Earth and this is our axis of rotation. Similarly, this is the side view and this is the axis of rotation. Now we all know that our Earth rotates at an angle of 23 point something with respect to the vertical line. But this angle or this point of our rotation also continues to change over the years. You can see here that our axis of rotation of Earth is also varying over the time. So this kind of movement is called precession. The time period for this precession to occur, that is this line of axis to cover one full circle, is 26,000 years. So remember, this is not a very fast process that we observe. It takes a lot of time for this to occur. This is a very slow process, and the forces which cause precession of axis are due to the gravitational force of Sun, Moon and planets. So you understand that whole of our solar system is balanced under different forces, that is gravitational force of Sun, gravitational force of Moon, Mars, Jupiter, and all these planets, they exert gravitational force on each other, and it is the complete equilibrium of these forces that led to the formation of solar system. But certain variations cause certain variations in the rotation of our axis, and this is a periodic cycle. So Wegner was of the thought that because of this constantly changing axis, there must be a force which might be causing a change in location of the continental plates. Now, why this theory got rejected? As we have already seen, most of the evidences that he suggested were basically observational. The theoretical things that he tried to do were not up to the mark and were right out rejected. So all the forces that he calculated were rejected because they were found to be very small and insignificant. The tidal forces suggested if it were of the same amount, then Earth would have stopped rotating a long time ago. So it was not possible for the tidal forces to cause continental drift. He said that Sial, that is the continental crust, moves over the oceanic floor very smoothly. But if we see the calculations of these things, then if it is actually moving, then it would severely distort the margins of these continents, and it would be impossible for the alignment of the continental coasts, as he has suggested in his jigsaw fit. So geophysicists suggested that this is not possible because a lot of friction will be generated by this kind of movement, and moreover it would distort the continents to a very higher degree. Then we have seen that he has suggested that fossils of organisms were distributed. Now remember, in the beginning we had talked about the contracting earth theory and the land bridges. So the scientists said that it would be the land bridges due to with the help of which these organisms must have crossed from one location to another location, and that is how this argument was rejected. Moreover, Wegner actually failed to explain the orographic events that occurred 200 million years ago, or that occurred before the formation of Pangea. We have already seen that he has said that Caledonian and Hercynian mountains were formed way before 200 million years ago, but there was no idea in his theory that how these might have formed. So it was because of this inconsistency in the forces that he suggested or the support he provided were not sufficient enough. That is why his theory got rejected. But his theory was not a complete loss. It inspired a lot of people. A lot of people supported his theory, and they worked in the same lines for giving proofs for that theory. In fact, in 1928, Arthur Holmes came up with the convection cell theory. And this theory became in the future one of the major forces for explaining how our tectonic plates move. It inspired people to come up with different ideas, and that is what led to the seafloor spreading and plate tectonics theory. So in that regards, this was a very major stepping stone. In the next video, we will discuss about seafloor spreading theory. So please join us there. Notes for all the topics that we discussed will be available on our website zeta-axis.com. Thanks for watching the video, and if you like the video, please like, subscribe and share. If you like our effort and like what we are doing, then you can use our UPI ID or Patreon ID to support us. You can follow us on our social media links. Until then, we meet again. Jai Bharat, Jai Gyan. Thank you.